All right, let's talk about something we all know and love, ice cream. It's a classic, right? But what if you could take that everyday treat and completely reinvent it, just by applying some basic science to a real-world problem? Well, that's exactly what we're diving into. A story about chemistry, a little bit of struggle, and the quest for the perfect scoop.
So here's the big question right off the bat. How in the world can you make ice cream with liquid nitrogen? I mean, we're talking about something that's minus 321 degrees Fahrenheit. It's so cold, it seems impossible. How do you go from that to a creamy, delicious dessert without just ending up with a frozen rock? That is the puzzle we're going to solve.
Now, you'd think a story about high-tech ice cream would start in some fancy lab, but nope. This story starts in a much more down-to-earth place, a struggling burrito shop. The founder, Jerry Hancock, who actually has a chemistry background, was facing a problem every entrepreneur dreads.
The situation was pretty straightforward. His burrito franchise just wasn't pulling in enough cash. He knew he had to add something new to the menu. So, what did he do? He asked his customers what they wanted. And their answer was overwhelming: ice cream.
But here's where things get interesting. When he started talking to big ice cream manufacturers to get advice, they all gave him the same stark warning. The market was flooded. They told him, don't even think about getting into ice cream unless you can do something totally different. And that one piece of advice, it changed everything.
So, different became the new mission. But what does different actually mean to someone buying ice cream? Jerry started digging in, trying to figure out what people really wanted that they weren't getting anywhere else.
And the big aha moment wasn't about coming up with some wild new flavor. It was about giving people control. The real desire was for total customization. The ability to choose your base, pick any flavor, throw in any mix-ins you want, and watch it get made fresh right there in front of you. Okay, so to make ice cream on demand like that, you need to freeze it, and freeze it fast. This is what led him to liquid nitrogen, something he was familiar with from his chemistry days. But the way people were making nitrogen ice cream at the time, well, it had a huge flaw. He called up his old chemistry colleagues, and they all basically said, yeah, we've tried that. It doesn't work. The result was always the same inconsistent mess. It would get hard and crusty around the edges of the bowl, but the middle would stay soupy and liquid. You definitely couldn't serve that to a customer.
So, let's break down why that old lab method was such a failure. The idea was to pour in a little bit of nitrogen, stir like crazy, pour a little more, and repeat. But all this did was freeze the mixture unevenly, giving you that lumpy, weird texture. It was a bust.
The root of the problem was a super simple physics concept: density. You see, liquid nitrogen is less dense than the ice cream mix. Think of it like oil and water. The oil just floats right on top. The nitrogen was doing the same thing, only freezing the surface it touched and leaving the rest of the mix alone. And this is the moment of genius. Instead of fighting against density, they decided to use it to their advantage. The solution? Add all of the nitrogen at once. This let the nitrogen float on top and create a perfect, solid frozen sheet. Then they use a special spade to break up that sheet, which lets the nitrogen sink and freeze the next layer down. They repeat this, freezing the ice cream perfectly, layer by layer. And that brilliant process, by the way, is now patented.
So they solved the main problem, but there is so much other cool science happening here that makes the whole thing work, keeps it safe, and let's be honest, it makes it look incredibly awesome. This is probably the first thing that pops into your mind, right? We're dealing with a liquid that is hundreds of degrees below zero. How is it not instantly dangerous to be around?
The answer is a really neat phenomenon called the Leidenfrost effect. You've actually seen this before. If you've ever dropped water onto a scorching hot pan, you see how the droplets kind of dance and skitter across the surface? That's it. The liquid nitrogen instantly vaporizes when it touches a warm surface, creating a protective cushion of gas that insulates you for a brief moment.
Now, what about all that dramatic fog that billows over the counter? It's the best part of the show, but it's not what you think it is. That fog is not nitrogen gas. Nitrogen gas is completely invisible, just like the air we're breathing. What you're actually seeing is just water vapor from the air around you getting super cold and condensing into a cloud. It's the exact same thing as seeing your own breath on a cold day.
So why is nitrogen a liquid in the first place? After all, it makes up most of the air around us. Well, it comes down to something called the ideal gas law. Put simply, this law just says that if you take a gas and drop its temperature way down, like to negative 321 degrees, you force it to compress and condense into a liquid.
Okay, so the science is cool, the process is ingenious, but does all of this actually make for better ice cream? Let's connect all this back to what really matters, the texture of that perfect scoop. And here's where you can actually see the proof. Under a microscope, on the left, you've got the nitrogen-frozen ice cream. Notice how the ice crystals are incredibly tiny and uniform? Now look at the right. That's traditional ice cream. The crystals are huge and jagged. Your tongue can feel those jagged edges. We perceive it as icy or less smooth. The key is speed. The faster you freeze it, the smaller the ice crystals are.
And how much faster are we talking? The entire freezing process, from a liquid base to a solid scoop of ice cream, takes about 15 seconds. Just 15!
Now, compare that to how regular ice cream is made. There's an initial freeze that can take up to 20 minutes. Then, it has to go into a hardening cabinet for at least 8 hours before it's ready to be stored and served. We're talking about a multi-hour, sometimes multi-day process versus just 15 seconds. And that's the whole secret. It all comes back to the size of those ice crystals. Because the nitrogen freezing is almost instant, the water crystals have no time to grow big and jagged. They stay microscopic, so your tongue can't even feel them. The result is just an incredibly smooth texture. It's fresh, it's delicious, and really, it's just science. So, when you think about it, a failing burrito shop, a simple question, and a clever bit of chemistry completely transformed a dessert we thought we knew inside and out. It really makes you wonder, doesn't it? What other everyday things are just sitting there waiting for their own scientific breakthrough?